Hello viewers, I go by the name Elective. In today's video, I am going to introduce you to matrices. Follow me by clicking on the subscription button and press on the notification bell for any new videos that I will upload. And again, you can join my live Telegram sessions at the link provided in the comment section below. Let's start. Let's define a matrix. A matrix is a rectangular array of numbers. The numbers in the matrix are called the elements. When we say matrix is 1, but when it is more than 1, we call it matrices. So these are a few examples. Example 1, example 2, example 3. And the numbers are what refers to as the elements. So example 1 has the element of 2, 5. Example 2, 5, 7, 2, 3. Example 3, we have 2, 4, 10, 3, 7, 8. So this is how you represent matrices. Now the order of matrix is by the rows and the columns. So the M here represents the rows and the N represents the columns. Now let's look at the types of matrices. Matrices are denoted by a bold letter. So it can be letter A, it can be letter B, letter C. For this first example, A sub 1, 1 is the element of this matrix. A sub 2, 1 is the element. Someone may ask, what is this sub 1, 1? From the beginning, I said the order of matrix is by rows and column. So the rows come first, then columns. The 2 represent the number of rows and the 1 represents the number of columns. That is the order. So this matrix here is 2 by 1 because it has 2 rows. Let's check. Row 1, row 2. How many columns? Column 1. So the position of A sub 1, 1 is A, row 1, column 1. The position row 2, column 1. Now, the rows are in horizontal array. The rows, which are the horizontal array, and the columns are the vertical arrays. So let's check this. How many rows do we have here? 2 rows. Row 1 and row 2. How many columns? Column 1, column 2, column 3. And we said the order of matrix is rows by columns. So the order of this particular matrix, example 3 over here, is 2 by 3. Any matrix that has only 1 column. So this matrix here like this has just 1 column. It has just 1 column. Therefore, it's a column matrix. It's a column matrix. So that is one type. Let's get to number 2. Example 2. We have B element. Is the same as 3 and 6. We can also represent matrices in this form. Now, a matrix that has only 1 row. How many rows? 1. 1 row. That matrix is called a row matrix. Let's look at example 6. Let's check the elements. How many elements are here? We have 4 elements. How many rows? Row 1, row 2. How many columns? That's here. Row 1, row 2. How many columns? Column 1, column 2. And this is 2 by 2 matrices. That is the order. Now, a matrix that has the same number of rows as column, that matrix, we turn it as a square matrix because the number of rows and the number of columns are the same. So it's a square matrix. Example D. How many elements do we have here? We have 6 elements. And how many rows? Let's check the order. Row 1, row 2. Let's check the columns. Column 1, column 2, column 3. The same over here. Row 1, row 2. Column 1, column 2, column 3. So the order of this matrix is 2 by 3 matrix. 2 by 3. Now, what type of matrix is this? A matrix which the number of rows is not equal to the number of columns is called a rectangular matrix. So, let's check. Is the number of rows equal to the number of columns? No. We have 2 rows and 3 columns. Therefore, this is a rectangular matrix. Now, example 3. Example. Row 1, row 2, and row 3. How many columns? Column 1, column 2, and column 3. So the order of this matrix is 3 by 3. 3 by 3. But guys, watch here carefully. In this matrix, example E, we have the leading diagonals to be 1, 1, 1, 1. And the non-diagonals are 0, 0. These are the non-diagonals. They are all 0. And this is also a square matrix, true or false? True, because the number of rows and the number of columns are the same. We have 3 rows, row 1, row 2, row 3. And how many columns? Column 1, column 2, and column 3. So it's a square matrix. But just the leading diagonals tell us that this is an identity matrix or a unit matrix. So any matrix in this form, we term this matrix as what? A unit matrix or an identity matrix. And know that when you use identity matrix to multiply any matrix, it will give you the same matrix. It will give you the same matrix. So this is the identity matrix or unit matrix. Let's go to type 6. Looking at this matrix here, we have all the elements to be 0, 0. This is 3 by 3 and this is 2 by 2 because this has 2 rows and 2 columns. So the order of this matrix is 2 by 2 and it is a square matrix. Now, because of the elements which are 0, 0, this matrix is termed as a null matrix or zero matrix. Let's go to the type 7. Now, this matrix A, when you watch carefully, you see that the leading diagonals, the elements are not the same. So we cannot say that this is an identity matrix or a unit matrix. For identity, all the leading diagonals are 1, 1, 1, and the non-leading diagonals are 0. So this matrix in this form is called a diagonal matrix. And this 2 by 2, 2 is a diagonal matrix because it's a square matrix, and again, the leading diagonals are not the same. Let's take this quiz. You can pause the video to see if you can solve this. Now, what is the position of the following elements? We have A, we have I, we have G, and E in the matrix below. What are their position? What is the position of A? What is the position of E? What is the position of G? What is the position of I? You can pause the video to test yourself. All right. If you have done that, let's check the answers. The answer for A. What is the position of A? We read matrix by rows and column. Rows and column. So the A is at row 1, then position column 1. We have it here. What of I? We read matrix or we determine the position by rows and column. This is I over here. What is the row? Row 1, row 2, row 3. So I is at row 3. Then what column? Column 1, column 2, column 3. So the position of I is row 3, column 3. What of G? G we determine by rows and column. G is at row 3. Row 3. Then what column? Column 1. So G is row 3, column 1. That's the position. What of E? What is the position of E? E is at row 2. Then the column is column 2. So E is row 2, column 2. Now, another question. What is the order of the matrix from equation 1? This matrix. Pause the video. We determine the order of matrix by rows and columns. So let's check how many columns do we have here and how many rows do we have here. Row 1, row 2, and row 3. So we have 3 rows. Column 1, column 2, and column 3. So the order of the matrix is 3 by 3 matrices, and it's a square matrix. All right. Let's take another type. When we say equal matrices, 2 matrices are said to be equal if their corresponding entries are the same. So with this matrix, let's say this is matrix A and matrix B. we are comparing, they are corresponding. So when we take the first element here, let's compare with the first element in the first row. So A goes with E, B goes with F, C goes with G, D goes with H. Did you see how simple this is? So these are the corresponding elements. With the corresponding elements or equal matrices, this will help us in solving for addition of matrices and subtraction of matrices by comparing their corresponding entries. All right, let's take another example. This is 3 by 3 matrices. Let's compare their corresponding entries. So A goes with 10, B goes with 8, C goes with 6, D goes with 8, E goes with 7, F goes with 9, G goes with 11, H goes with 9, I goes with 12. So these are their corresponding entries. Now, quiz 2. What is the corresponding entries of the following elements? A sub 1 1, A sub 1 2, A sub 2 1, A sub 2 2. Pause the video to check whether you get the same answer. Let's compare. A sub 1 1 goes with 5, A sub 1 2 goes with 7, A sub 2 goes with 2, A sub 2 2 goes with 3. So this is the final answer. Please, thank you for watching. Please don't forget to share. Share.